friends, we are happy to be back with another informative unit. If you want to add more to your knowledge of power system, this is what you want to follow. Before starting with our Unit 2, please make sure that you have watched and completed the first unit. That way, you will be very much comfortable with the content of Unit 2. As of our previous video on generating station lesson 1 part 1, we have just got to the schematic diagram of steam power plant. And we have divided the whole plant into the 6 parts. The first one is coal and ash handling system. In coal and ash handling plant, coal is transported by any means of transportation and is stored in coal storage plant. Then from coal storage plant, the coal is delivered to coal handling plant, where it's pulverized. Pulverization is done to crush the coal into smaller pieces, and this will increase its surface exposure. Then the pulverized coal is fed to the boiler. The coal is burned in boiler and the ash produced after the complete combustion of coal is removed to the ash handling plant and then delivered to the ash storage plant for disposal. So friends, let's have an example here. If we consider a station operating at 50% of its load factor and is generating 200 megawatts, for generation of 200 megawatts, it will need 40,000 tons of coal to be burned. So, after the complete combustion of 40,000 tons of coal, the ash produced is 4,000 tons. 4,000 tons. 2. Steam generating plant. Steam generating plant consists of boiler, superheater, economizer, and air preheater. The heat of combustion of coal in boiler is utilized to convert water into steam at high temperature and pressure. The flue gases from the boiler make their journey to superheater, economizer, air preheater, and is finally exhausted to atmosphere through chimney. So why do we have superheater here? The steam produced in the boiler is wet and is passed through a superheater where it's dried and superheated. Superheater provides two basic benefits. First, the overall efficiency is increased, and second, too much condensation in the last stage of turbine is avoided. Air preheater. An air preheater increases the temperature of the air supplied for coal burning by driving heat from flue gases. Steam turbine. The dry and superheated steam from the superheater is fed to steam turbine through main valve. The heat energy of steam when passing over the blades of turbine is converted into mechanical energy. After giving heat energy to the turbine, the steam is exhausted to the condenser, which condenses the exhausted steam by means of cold water circulation. Alternator. The steam turbine is coupled to an alternator. The alternator converts mechanical energy of turbine into electrical energy. The electrical output from the alternator is delivered to the bus bars through isolated circuit breakers and transformers. Now, feed water and cooling arrangement. In order to improve the efficiency of plant, the steam exhausted from the turbine is condensed by means of a condenser. Water is drawn from a natural source of supply, say river, canal or lake, and is circulated through the condenser. The circulating water takes up the heat of exhausted steam and itself becomes hot. The hot water coming out from the condenser is discharged at a suitable location down the river. The following points has to be taken into consideration while selecting a site for steam power plant: supply of fuel, availability of water, transportation facilities, cost and type of land, distance from populated area. It is clear that all the above factors cannot be favorable at one place. So keeping in view the fact that nowadays supply system is easier and more importance is being given to the generation than transmission, a site away from towns may be selected. In particular, a site by riverside where sufficient water is available and no pollution to the environment and fuel can be transported economically may perhaps be an ideal choice. Efficiency. As we have said previously that for generation of 200 megawatts of electrical energy we need 40,000 tons of coal, and by burning 40,000 tons of coal the ash produced will be 4,000 tons. So keeping that in mind, we can say that the overall efficiency of a steam power plant is 25 to 30%, and that is due to the heat loss. Greater the temperature difference, greater is the heat loss, and that is according to thermodynamic laws. thermal efficiency, the ratio of heat equivalent of mechanical energy transmitted to the turbine shaft divided to the heat of combustion of coal is known as thermal efficiency of steam power plant. Overall efficiency, the ratio of heat equivalent of electrical output divided to the heat of combustion of coal is known as overall efficiency of steam power station. And that brings us to the end of this video. See you all in next video. Bye.